Why are reactions exothermic or endothermic? By KayScience.com. In any chemical reaction, reactants are always on the left and products are always on the right. Here are some made-up reactants on the left and then some made-up products on the right. Notice how the bonds between the atoms in the reactants have been broken, and then these atoms have formed new bonds to make new products. This is what takes place in a chemical reaction. So in any chemical reaction, the first thing that takes place is the bonds need to break between the atoms in the reactants. And breaking bonds always requires energy, and this energy is taken in from the surroundings to break the bonds. So a very important rule to remember is bond breaking always takes in energy from the surroundings. This means bond breaking is endothermic, as energy is being taken in from the surroundings to break the bonds between the atoms in the reactants. It's question time. Attempt these questions to check your understanding. So here are the individual atoms as their bonds have been broken. The movement lines show how they are able to move freely. For a chemical reaction to take place, these atoms must collide and they must have the activation energy, which is the minimum amount of energy for a reaction to take place. So the products show how the circle is now bonded to the square and it is also bonded to the triangle. This means new bonds have formed. Bond making always releases energy into the surroundings, as shown by the arrows. This is a rule you must remember. These arrows show energy is always taken in from the surroundings when breaking the bonds of the reactants. So just to clarify the second rule, bond making always releases energy into the surroundings. This means every time atoms collide with enough energy and form bonds, they will release energy into the surroundings. Therefore, bond making is exothermic as energy is always released into the surroundings. It's question time. Attempt these questions to check your understanding. So you need to make sure you know that breaking bonds in the reactants always takes in energy from the surroundings. This happens every single time. Whereas making bonds in the products always releases energy into the surroundings. Learn these two rules and you will understand why a chemical reaction is exothermic or endothermic. So now we've learnt these two rules, we're going to understand why a chemical reaction is exothermic. Remember, an exothermic reaction is where the temperature of the surroundings increases. Yet, if energy is always taken in from the surroundings to break down the reactants, how comes a chemical reaction can be exothermic? Well, if more energy is given out when making the bonds, and less energy is taken in when breaking the bonds, then the reaction will be exothermic, as overall more heat energy is released compared to what was taken in. Therefore, the temperature of the surroundings will increase, making it an exothermic reaction. We can use the equation overall energy change equals total energy in take away total energy out to understand this in more detail. So if 1000 kilojoules per mole was needed to break the bonds, and 2000 kilojoules per mole was released when forming the bonds, then the energy change is minus 1000 kilojoules per mole. This is a negative energy change as the products have less energy stored compared to the reactants. Overall, more energy has been released than taken in, so this is exothermic, whereas an endothermic reaction causes the temperature of the surroundings to decrease. Yet if bond making always releases energy into the surroundings, causing the temperature to increase, how comes overall the temperature of the surroundings can decrease in an endothermic reaction? Well, if more energy is taken in when breaking the bonds and less energy is released when making the bonds, then overall the reaction will be endothermic. Let's use the same equation. Overall energy change equals total energy in, take away total energy out, to understand this in more detail. Well, for example, if 3000 kilojoules per mole was needed to break the bonds and 1000 kilojoules per mole was released when forming the bonds, the overall energy change would be 2000 kilojoules per mole. This is a positive energy change as the products have more energy stored compared to the reactants. So overall, more energy was taken in than released, so it's endothermic. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets, and quizzes at KayScience.com. And don't forget to like and subscribe.